A black hole is a region in space where gravity is so strong that nothing, not even light, can escape it. Scientists believe black holes form when massive stars collapse under their gravity at the end of their life cycles. Black holes are fascinating because they challenge our understanding of physics, especially in areas where general relativity and quantum mechanics overlap. So in today's video, we will know everything about black holes that scientists have discovered so far. But before I start, make sure you subscribe to Sourashis for cosmic content and press the bell icon. Thank you. If you don't know about black holes, let me tell you, a black hole is a region in space where gravity is so strong that nothing, not even light, can escape from it. This happens when a huge amount of matter is squeezed into a very small space, making gravity incredibly powerful. Black holes form when very massive stars come to end of their life cycle. A star is like a giant ball of gas, mostly hydrogen, held together by gravity. It shines because of nuclear fusion, where hydrogen atoms combine to form helium, releasing energy. Over time, the star burns through its fuel. When the fuel runs out, it no longer has the energy to fight against its own gravity. If the star is massive enough, its core becomes unstable. Gravity pulls everything inward. This collapse happens super quickly, like an explosion going inward instead of outward. The collapsing core gets squeezed into an incredibly tiny and dense point called a singularity. Around this singularity, gravity becomes so strong that not even light can escape. This creates the event horizon, the point of no return. There are 4 types of black hole in the universe. The first one is stellar black hole. When a massive star, about 8 times the sun's mass, burns out its nuclear fuel, it can no longer support itself against gravity. The core collapses into a super dense point, and the outer layers may explode in a supernova. If the core's mass is high enough, it forms a black hole. Strong gravitational pull affects nearby objects, causing observable effects like X-ray emissions when matter falls in. These are the easiest black holes to study because their smaller size allow for noticeable effects, such as pulling material from nearby stars. Next one is supermassive black holes. These are thought to form from the gradual merging of stellar black holes, gas accumulation, or even direct collapse of massive clouds in the early universe. Over billions of years, they grow by eating stars, gas, and merging with other black holes found at the center of most galaxies, including our Milky Way. Their immense gravitational influence shapes galaxy formation and behavior. Event horizons can span millions of kilometers. Supermassive black holes power quasars, extremely bright objects that are some of the most distant things we can observe. Next, intermediate black holes. They likely form when smaller black holes merge or when a single star cluster collapses. They may act as the seeds for supermassive black holes over time. Intermediate black holes, less massive than supermassive black holes, but much larger than stellar black holes. Their event horizons are moderate in size, and they can still produce observable X-ray flares or gravitational wave signals when they merge. These black holes are rare, and finding them helps the astronomer bridge the gap in understanding black hole growth. Some candidates have been found, such as the one near the galaxy ESO 24349. And the last one, primordial black holes. These theoretical black holes created moments after the Big Bang. High-density regions in the early universe could have collapsed under their own gravity to form these black holes. These black holes could range from microscopic sizes to larger masses. Unlike other black holes, these may not form from stars, but rather from quantum fluctuations in the early universe. They might explain some mysteries like dark matter, as their gravitational effects could account for unseen mass in the universe. Small primordial black holes might have evaporated through a process called Hawking radiation. The event horizon is the point of no return around a black hole. Once something crosses it, even light cannot escape. Imagine it as an invisible boundary. Outside this boundary, you can still escape if you are fast enough. Inside, there's no way out. Near the black hole, time moves slower for an object compared to someone far away. If you were near a black hole and looked at a clock far from it, the clock would seem to move much faster than yours. The gravity near a black hole is incredibly strong and uneven. If you fell toward a black hole, your feet closer to the black hole would feel much more pull than your head. This should stretch you out like a spaghetti, a process called spaghettification. Black holes bend space-time around them. This means light from stars beyond the black hole gets bent around it, creating a gravitational lens. You might see distorted or multiple images of the same star if a black hole is feeding gas, dust, and even stars can get caught in its pool. These materials spiral into the black hole, forming a glowing disk called an acceleration disk. This disk gets very hot and emits bright X-rays. Sometimes black holes shoot out powerful jets of particles at nearly the speed of light. These jets come from the energy of the material falling into the black hole, not the black hole itself. Deep inside a black hole is the singularity, a point where all the matter is crushed into infinite density. Physics as we know it breaks down here. Scientists don't fully understand what happens. Black holes are invisible because they don't let light escape, but we can detect them by looking at their effects on nearby stars and gas. Scientists also use powerful telescopes to capture images of the material swirling around a black hole, which glows due to extreme heat. In 2019, scientists captured the image of a supermassive black hole in the galaxy MH7 using the Event Horizon Telescope. Black holes evaporate through a process called Hawking radiation, which was discovered by the physicist Stephen Hawking in 1974. The key idea is that black holes aren't completely isolated. They interact with the quantum nature of space. Hawking radiation lets the black hole leak energy back into the universe, even though nothing can escape its event horizon. This is because the escaping particles don't come from inside the black hole, they from just outside it. When the black hole becomes very small, its evaporation speeds up. It releases more energy in its final moment and might end in a tiny burst of radiation. This process is extremely slow for large black holes. For example, a black hole with the mass of the Sun would take about 10 unbijin trillion years to completely evaporate. Only small black holes like the ones theorized to have formed in early universe could evaporate within the age of the universe. This is why black hole evaporation is fascinating but hard to observe directly. It is a very slow process for the massive black holes we know of. So, what is your opinion on black holes? I really want to know. Don't forget to let me know in the comments. And also don't forget to tell me which space journey would you like to go on next. Thanks a lot for watching the full video. See you in the next video. Stay well.